Hello everyone, today we will learn about the application of graphs and properties of trigonometric functions. We have learned about the graphs and properties of sine functions, cosine functions, and tangent functions in the previous classes. Do you all remember what was included? Let's review it together with images. For a sine function y equal to sine x, its domain is the set of real numbers. Its minimum positive period is to pi. We can first draw an image within one cycle using the 5-point method. The coordinates of these 5 points are 0, 0, half pi, 1, pi, 0, 3 seconds of pi, -1, and to pi, 0. Through observation, we found that its minimum value is -1 and its maximum value is 1, with a closed range of values from -1 to 1. Then we expand to the entire image by copying and pasting. Let's observe it. We found that the entire image is symmetrical about the origin. The function is an odd function. When we study monotonicity, the interval we take is not a closed interval from 0 to 2 pi. The interval taken is a closed interval from the -half of pi to the positive 3 second of pi. Combining periodicity, we obtain a monotonically increasing interval from 2k pi minus half pi to 2k pi plus half pi, where k belongs to z. The monotonically decreasing interval is from 2k pi plus half pi to 2k pi plus 3 seconds of pi, where k belongs to z. Next, let's take a look at the image and properties where y equals cosine x. Y equals cosine, and the image of x can be seen as y equals sine x, obtained by translating the image of x. Through the image, we found that its domain of definition is the real number set. Its range is a closed interval from -1 to 1. The minimum positive period is to pi. The image is symmetrical about the y-axis. The function is an even function. When studying the monotonicity of cosine functions, the selected interval is not a closed interval from 0 to 2 pi. The interval we have chosen is a closed interval from -pi to pi. Combining periodicity, we can obtain a closed interval of monotonically increasing from 2k pi minus pi to 2k pi, where k belongs to z. The monotonically decreasing interval is a closed interval of 2k pi to 2k pi plus pi, where k belongs to z. Now let's take a look at the tangent function y, which is equal to tangent x. The graph and properties of tangent functions have undergone significant changes compared to sine and cosine functions. The independent variable x no longer takes any real number. X is not equal to k pi plus half pi, and k belongs to z. Its range of values is not a closed interval from -1 to 1, but rather a set of real numbers. We can observe from the image that its period has also changed. The original period was to pi, but now it has changed to pi. From the image, the entire image is symmetrical about the origin. The tangent function should be an odd function. When studying the monotonicity of tangent functions, the selected image within a period is as follows. The selected interval is an open interval from -half pi to half pi. By combining periodicity, we can obtain a monotonically increasing interval of k pi minus half pi. To the open interval of k pi plus half pi, k belongs to z. Above, we reviewed the 5 properties: domains, eigenvalues, periodicity, parity, and monotonicity of trigonometric functions using graphs. Next, we will combine these properties to study several more complex functions. Example 1. Find the symmetry center of the graph of the following function. The first question is that y is equal to sin x minus 1/4 of pi. Let's take a look at the connection between this function and the function where y equals sine x. The image where y is equal to sine x minus 1/4 of pi. It is obtained by parallel movement of the image with y equal to sine x. So, their shapes are exactly the same. Therefore, each intersection point between the image and the x-axis is the center of symmetry of the image. If its center of symmetry is required, only the 0 point of the function needs to be identified. The answer process is as follows. Let sine x minus 1/4 of pi equals 0, resulting in x minus 1/4 of pi equals k pi, and k belongs to z. Solving x equals k pi plus 1/4 of pi. We obtain the symmetry center of the function graph as k pi plus 1/4 of pi, 0, and k belong to z. Let's take a look at the second question again. equals to tangent x plus 1/6 of pi. The image with y equal to tangent x plus 1/6 of pi can be obtained by parallel movement of the image with y equal to tangent x. The shapes of the two are also completely same, as shown in the figure. So to obtain the center of symmetry of the image, we found that all we need is a tangent value of 0 or a meaningless value of x. That is to say, we need to make x plus 1/6 of pi equal to half k pi, and k belongs to z. The answer process is as follows. Let x plus 1/6 of pi equal half k pi, where k belongs to z. The solution is x equal to half k pi minus 1/6 of pi. So the symmetry center of the function graph is half k pi minus 1/6 of pi, 0, k belongs to z. Now let's take a look at the set of exercises. Given that the function fx is equal to cosine x plus, is greater than or equal to 0 and less than or equal to pi, the first question is, if the function fx is an odd function, find the value of. The second question. The symmetry axis of the graph of function fx is the straight line x equal to 1/8 of pi. Find the value of. Let's first take a look at this function. The image with fx equal to cosine x plus can be obtained by translating the image with cosine function y equal to cosine x. The shapes of the two are completely same. We found that the cosine function graph is both axisymmetric and centrosymmetric. Each intersection point between the image and the x-axis is its center of symmetry, a straight line passing through the highest or lowest point and perpendicular to the x-axis. They are all its axis of symmetry. Let's first take a look at the first question. The answer is as follows. As the question implies, the graph of function fx is symmetric about the origin, so the origin should be the intersection of the image and the x-axis. So f0 is equal to 0. This yields cosine equal to 0. Then, based on the definition of the cosine function, we can obtain that is equal to k pi plus half pi, and k belongs to z. Furthermore, since is a closed interval from 0 to pi, so k can only take 0, which gives equal to half pi. So in fact, we can also look at this problem through image transformation, because is greater than or equal to 0 and less than or equal to pi. So the image of fx can be seen as the left translation of the image with y equal to cosine. Please compare these two pictures and we will find that y is equal to the image of cosine x, shifted to the left by half pi units of length. Is it about the symmetry of the origin? By doing so, we can also obtain that is equal to half pi. Please also note that when studying the parity of sine and cosine functions, we generally do not use the definition of parity, which means we do not need to calculate f negative x and fx for comparison, but rather solve the problem through images. Okay, let's take a look at the second question. Because the title states that the axis of symmetry is a straight line x equal to 1/8 of pi, the function value corresponding to 1/8 of pi must be either the maximum or minimum value. The answer process is as follows. It can be inferred from the meaning of the question. F 1/8 of pi is equal to positive or negative 1. Cosine 1/8 of pi plus equal to positive or negative 1. We can derive from the definition of cosine function that adding 1/8 of pi to equals k pi, where k belongs to z. The solution is that is equal to k pi minus 1/8 of pi. Also, because is greater than or equal to 0 and less than or equal to pi, so the value of is 7/8 of pi. Earlier, we studied some characteristics of the graph of trigonometric functions under translation transformation. Let's briefly summarize below. Point 0, 0 is the center of symmetry of the sine curve fx equal to sin x plus, equivalent to f of being equal to 0. 2. The straight line x equals a, which is the symmetry axis of the sine curve fx equal to sin x plus, equivalent to fa equal to plus or minus 1. The same applies to cosine curves. 3. Point A, 0 is the symmetry center of the tangent curve fx equal to tangent x plus, equivalent to a plus being equal to 2k pi. K belongs to z. Next, we will study the graphs and properties of trigonometric functions with absolute values. Example 2. Find the monotonic interval of the following function. Y is equal to the absolute value cosine x. Y is equal to the absolute value tan x. From these two analytical expressions, it can be seen that trigonometric functions have added an absolute value sign. We should have known in the previous chapters of our study. Folding the image below the x-axis with y equal to fx yields an image with y equal to the absolute value fx. This is called folding transformation. Let's take a look at the first question, the image where y equals the absolute value cosine x. We found that its period should be pi. To find its monotonic interval, we selected an image within one cycle. The selected interval is a closed interval from -½ pi to +½ pi. We found that it increases in the closed interval from -½ pi to 0. It decreases in the closed interval from 0 to ½ pi. Then combined with periodicity, we can obtain its monotonically increasing interval as the closed interval from k pi minus ½ pi to k pi, where k belongs to z. The monotonically decreasing interval is the closed interval from k pi to k pi plus ½ pi, where k belongs to z. Let's take a look at the second question again. Its image looks like this. We can obtain it by observing the image. The cycle is still pi. We selected images within one cycle for study, and the selected interval is the open range from -½ pi to +½ pi. We found that the function decreases in the left open right closed interval from ½ pi to 0. On the left closed and right open interval from 0 to ½ pi, the function is increasing. By combining this with periodicity, we can obtain the monotonically increasing interval is the left closed and right open interval from k pi to k pi plus ½ pi, where k belongs to z. The monotonically decreasing interval is the left open and right closed interval from k pi minus ½ pi to k pi, where k belongs to z. Next, we will continue to study the following two questions. What symmetry does the graph of function y equal to the absolute value cosine x and y equal to the absolute value tangent x have? Let's first take a look at the image where y equals the absolute value cosine x. Through observation, we have obtained this image is an axisymmetric figure. It is not a centrally symmetrical thing, and the axis of symmetry is x equal to ½ k pi, where k belongs to z. Let's take a look at the graph where y equals the absolute value of tangent x. From the image, it can be seen that this image is an axisymmetric shape, but it is also not a centrosymmetric shape. So the equation for its axis of symmetry is the same as before, where x equals ½ k pi and k belongs to z. Let's take a look at the second question again. Does the property of function y being equal to the absolute value cosine x plus 1 change compared to function y being equal to the absolute value cosine x? We still compare by observing the images. We can observe that the image with y equal to the absolute value cosine x plus 1 is a translation of the image with y equal to the absolute value cosine x by 1 unit length. So it can be concluded that its domain, periodicity, monotonicity, parity, and symmetry axis equation have not changed. What has changed? It is its range of values. The range of the function above is a closed interval from 0 to 1, while the function below is a closed interval from 1 to 2. Let's summarize today's lesson on the symmetry of trigonometric function images under translation and folding transformations, as well as the periodicity and monotonicity of trigonometric functions. Further understanding of the role of images and properties reflects the idea and method of combining numbers and shapes. The specific content includes the first 3 points that we have summarized earlier, and the fourth point is about the research methods for the graphs and properties of trigonometric functions with absolute values. Please pay attention. That's all for today's class. Goodbye, everyone.